The Oracle database, a behemoth in the realm of relational database management systems, stands as a cornerstone of the technological landscape. Its robust architecture, designed for scalability and reliability, has cemented its place as the preferred choice for organizations worldwide, handling data-intensive operations across diverse industries. From financial transactions to scientific research, Oracle's capabilities cater to a vast spectrum of data management needs. Its enduring popularity stems from its ability to seamlessly manage and manipulate vast volumes of data while maintaining utmost integrity and availability. This essay embarks on a journey to unravel the intricacies of Oracle's architecture, delving into the core components that underpin its power and efficiency. Our exploration will focus on three fundamental elements: the Oracle server, the Oracle instance, and the physical structure. Each component plays a distinct role in the overall functioning of the database, and understanding their individual contributions is crucial to comprehending the system as a whole. By unraveling these layers, we aim to provide a comprehensive yet accessible overview of Oracle's architectural brilliance, catering to both newcomers seeking foundational knowledge and seasoned professionals seeking a deeper understanding of the system they interact with daily. The Oracle server, the bedrock of the Oracle database system, provides the foundational software environment where the magic of data management unfolds. It is responsible for managing all the physical files that constitute the database, orchestrating their interactions, and ensuring their seamless operation. Think of it as the grand conductor of an orchestra, ensuring every instrument plays its part in perfect harmony. At its core, the Oracle server comprises two key components: the database processes and the memory structures. The database processes, the tireless workers of the system, manage the flow of data, execute user requests, and maintain the overall health of the database. These processes are constantly active, diligently performing their assigned tasks to ensure the smooth functioning of the system. Memory structures, on the other hand, act as the information hub of the Oracle server. They store data that is actively being processed, user information, and other vital data required for efficient operation. This information is readily accessible, enabling the database processes to perform their duties with optimal speed and efficiency. Together, these components form the backbone of the Oracle server, ensuring the database operates reliably and efficiently. Their coordinated efforts provide the stable foundation upon which the Oracle instance can thrive, enabling the system to manage data with the precision and power that has become synonymous with the Oracle name. The Oracle instance, the dynamic engine that powers the Oracle database, breathes life into the static structures of the Oracle server. It is a collection of memory structures and background processes that work in tandem to manage and manipulate the data stored within the physical files. Imagine it as the beating heart of the system, constantly pumping data through its veins, keeping the database alive and responsive. The Oracle instance is created every time the database is started up, loading necessary data into memory and initiating the background processes that keep the system humming. This dynamic entity acts as the interface between users and the physical database, translating user requests into concrete actions on the data. A key component of the Oracle instance is the System Global Area, SGA, a shared memory region that stores data and control information for the entire instance. It acts as the central repository of information, enabling efficient communication and data sharing between different processes within the instance. The SGA is further subdivided into several memory structures, each serving a specific purpose. These include the database buffer cache, which stores frequently accessed data for rapid retrieval, the redo log buffer, which records changes made to the database, and the shared pool, which houses shared SQL and PL/SQL code for efficient execution. The Oracle instance, with its intricate network of memory structures and background processes, is the powerhouse that drives the Oracle database. It is through this dynamic entity that users can interact with the database, perform transactions, and extract meaningful insights from the vast ocean of data stored within. The physical structure of the Oracle database outlines the organization of the physical files that store the actual data. These files are the building blocks of the database, each playing a specific role in ensuring data integrity, availability, and efficient access. Think of them as the blueprints of a grand library, dictating how books are categorized, shelved, and retrieved. The physical structure is comprised of several key file types, each serving a distinct purpose in the overall functioning of the database. 1. Data files. These files contain the actual data stored within the database, including user data, tables, indexes, and other database objects. They are the core repositories of information, the bookshelves of our library analogy. 2. Control files. These files act as the system trackers, maintaining metadata about the physical structure of the database. They store information about data files, redo log files, and other essential components, ensuring the database knows where everything is located. 3. Redo log files. These files act as the change guardians, recording all changes made to the database. They provide a chronological log of every transaction, ensuring data can be recovered in case of failures. These files, along with other supporting components, form the physical blueprint of the Oracle database. Their organized structure ensures that data is stored securely, accessed efficiently, and protected against potential failures. This meticulous organization is crucial for maintaining data integrity, ensuring availability, and enabling the database to perform at its peak. Data files, the fundamental building blocks of the Oracle database, are the containers that hold the actual data that fuels the system. These files store everything from user information and tables to indexes and other database objects. They are the bookshelves of our library analogy, each shelf holding a different category of books, organized for efficient access and retrieval. Each database comprises at least one data file, but typically encompasses multiple data files organized into logical units called table spaces. Table spaces allow for granular control over data storage, enabling administrators to allocate specific data types to different physical disks for optimized performance and easier management. Data files can be created with a fixed size or configured to grow automatically as needed. This flexibility allows the database to scale seamlessly with growing data volumes, ensuring that storage capacity never becomes a bottleneck. Furthermore, data files can be mirrored, creating redundant copies of the data on different physical disks. This redundancy enhances data availability, safeguarding against data loss in case of disk failures. If one disk fails, the mirrored copy on another disk ensures that the data remains accessible, minimizing downtime and ensuring business continuity. In essence, data files are the core repositories of information within the Oracle database. Their organized structure, coupled with features like table spaces and mirroring, ensures efficient data storage, scalability, and high availability, making them crucial for maintaining data integrity and enabling the database to perform reliably under demanding conditions. Control files, the meticulous record keepers of the Oracle database, act as the system trackers, meticulously maintaining metadata about the physical structure of the database. These files act like the librarians in our library analogy, maintaining a detailed catalog of all the books, their locations, and their borrowing history. They store critical information about the database, including the database name and unique identifier, ensuring each database is properly identified and tracked. The location and names of all data files, providing a roadmap to where the actual data resides within the physical storage. The location and names of all redo log files, tracking the chronological log of changes made to the database, timestamps of database creation and recent structural changes, providing a historical record of the database's evolution. Control files are crucial for the database to operate correctly. When the database starts up, it reads the control files to identify the physical structure, locate all the necessary files, and ensure everything is in order before proceeding. To safeguard against data loss, multiple copies of control files are typically maintained on different physical disks. This redundancy ensures that even if one disk fails, the database can still access a copy of the control file and start up correctly, minimizing downtime and ensuring business continuity. In essence, control files are the meticulous record keepers of the Oracle database, ensuring the system always knows where everything is located and how it fits together. Redo log files, the vigilant guardians of data integrity in the Oracle database, act as a chronological log of all changes made to the database. They record every transaction, every modification, ensuring that no data is ever lost, even in the face of unexpected failures. These files are like the security cameras in our library, meticulously recording every book borrowed, returned, or even misplaced. Each time a transaction modifies data within the database, the changes are first written to the redo log buffer, a memory structure within the SGA. These changes are then written from the buffer to the redo log files on disk, creating a persistent record of every modification. This meticulous logging ensures that data can be recovered in case of failures. If the database crashes unexpectedly, the redo log files provide a step-by-step record of all changes made since the last successful backup. These changes can then be reapplied to the data files, restoring the database to its state before the crash, ensuring no data is lost. Redo log files are organized into groups, with each group containing multiple log files. This cyclical structure ensures that as one log file fills up, the system seamlessly switches to the next file in the group, providing a continuous record of changes without interruption. In essence, redo log files are the unsung heroes of the Oracle database, tirelessly working behind the scenes to ensure data integrity and enable efficient recovery from failures. Their meticulous logging of every change, coupled with their cyclical structure for continuous operation, makes them essential for maintaining data consistency and ensuring the database can weather any storm. The parameter file, the configuration master of the Oracle database, defines the characteristics and behavior of the database instance. It's like the rulebook of our library, outlining operating hours, borrowing limits, and other guidelines that govern how the library functions. This file contains a vast array of parameters that control various aspects of the database, including 1. Memory allocation. Parameters define the size of the SGA and its various components, dictating how much memory is allocated for different database operations. 2. Processes parameters control the number of background processes that run within the instance, influencing the database's ability to handle concurrent requests. 3. Storage parameters define how data is stored within data files, influencing data access efficiency and storage optimization. 4. Security parameters control user authentication, access permissions, and other security measures that protect sensitive data within the database. The parameter file is read when the database starts up, configuring the instance according to the specified settings. These settings define the operating environment of the database, influencing its performance, scalability, and overall behavior. Administrators can modify the parameter file to fine-tune the database's performance and adapt it to changing workloads. This flexibility allows the database to be optimized for specific needs, ensuring it operates efficiently and meets the demands of its users. In essence, the parameter file is the control panel of the Oracle database, enabling administrators to fine-tune its operation and tailor its behavior to specific requirements. The password file, the security guard of the Oracle database, safeguards user accounts and access privileges, ensuring that only authorized users can access sensitive data. It acts like the keycard system in our library, granting access only to authorized personnel, keeping unauthorized individuals at bay. This file stores encrypted passwords for user accounts that have been granted sysdba or sysaper privileges. These are powerful administrative accounts that have full control over the database, making it crucial to protect them with strong passwords and restricted access. The password file is used during database startup to authenticate users attempting to connect with administrative privileges. It ensures that only those with the correct credentials can gain access to these powerful accounts, preventing unauthorized users from tampering with the database or accessing sensitive information. Security is paramount in any database system, and the password file plays a vital role in maintaining a secure environment. By storing encrypted passwords for privileged accounts and controlling access to these accounts, it acts as the first line of defense against unauthorized access, safeguarding the integrity and confidentiality of the data entrusted to the database. In essence, the password file is a critical component of the Oracle database's security infrastructure, ensuring that only authorized users can access and manage the system. Its role in user authentication and access control makes it an indispensable tool for maintaining a secure database environment and protecting sensitive data from unauthorized access. Background processes, the silent workers of the Oracle database, are specialized processes that operate behind the scenes, tirelessly performing tasks that keep the database running smoothly and efficiently. They are like the maintenance crew in our library, ensuring the lights are on, the shelves are organized, and the environment is conducive for a pleasant reading experience. These processes perform a wide range of tasks, including 1. Database writer, DBWN. This process writes modified data from the database buffer cache to the data files on disk, ensuring data is persistently stored and protected against memory failures. 2. Log writer, LGWR. This process writes redo log entries from the redo log buffer to the redo log files on disk, ensuring all changes made to the database are permanently recorded. 3. Checkpoint, CKPT. This process synchronizes the data files and control files with the redo log files, ensuring a consistent state of the database and enabling efficient recovery from failures. 4. System monitor, SMON. This process performs instance recovery after system crashes, cleaning up temporary segments and rolling back incomplete transactions to ensure data integrity. 5. Process monitor, PMON. This process monitors other background processes, restarting them if necessary, and releasing resources held by terminated processes, ensuring the smooth operation of the system. These background processes, along with other specialized processes, work tirelessly behind the scenes, ensuring the database operates efficiently, recovers gracefully from failures, and maintains a consistent and reliable state. They are the unsung heroes of the Oracle database, quietly enabling the system to perform at its peak while users focus on their tasks. In essence, background processes are the silent workforce of the Oracle database, ensuring its smooth operation, efficient data management, and reliable performance. The Oracle database, a symphony of interwoven components, achieves optimal performance through the seamless integration and synergy of its core architectural elements. The Oracle Server, the foundation, provides the stable platform upon which the Oracle instance, the dynamic engine, operates, breathing life into the meticulously organized physical structure, the blueprint of data storage. The Oracle Server, with its memory structures and database processes, manages the physical files that constitute the database. The Oracle instance, comprising the SGA and background processes, interacts with these files, managing data access, transaction processing, and system recovery. The physical structure, encompassing data files, control files, redo log files, and other essential components, defines how data is stored, organized, and protected. Data files hold the actual data, control files track the system structure, redo log files record changes, and other components contribute to security, configuration, and efficient operation. These components, working in harmony, provide a robust and scalable platform for managing vast volumes of data. The Oracle instance acts as the dynamic interface between users and the physical database, translating requests into concrete actions on the data stored within the data files. Background processes diligently perform tasks that maintain data integrity, ensure system availability, and optimize performance. They manage data writing, log creation, system recovery, and other essential functions, keeping the database running smoothly and efficiently. The integration of these components ensures data integrity, high availability, and optimal performance. Data is protected against loss through meticulous logging and redundant storage. System availability is maximized through mirrored files and efficient recovery mechanisms. Performance is optimized through intelligent memory management, efficient data access, and streamlined background processes. In conclusion, the Oracle database's architectural elegance lies in the seamless integration of its core components. Each element plays a crucial role, contributing to a system that is robust, scalable, and capable of handling the most demanding data management challenges. By understanding the interplay of these components, one can truly appreciate the power and sophistication of the Oracle database, a testament to the art of data management.